You know, in the world of AI, there's this classic story playing out right now. It's a real David versus Goliath situation. But instead of slingshots and stones, we're talking about parameters and processing power. Today, we're diving into the incredible and kind of surprising rise of small language models. So when I say powerful AI, what pops into your head? For most of us, it's these massive systems, right? Things like GPT-4o, the true Goliaths of the tech world. For years, the mantra has been pretty simple. If you want smarter AI, you just have to make it bigger. But is that really the whole story? Is bigger always better? Okay, to really get the difference here, it all boils down to something called parameters. You can think of these as the neural connections the AI uses to think and learn. Now, the large language models, the Goliaths, have hundreds of billions of them. On the other hand, small language models get by with just a few million to maybe a couple billion. The difference in scale is just mind-boggling. But here's the catch, and it's a big one. That massive size comes with some serious baggage. These giant models are total power hogs, they're incredibly expensive to train and run, and they need the kind of computer infrastructure that's way out of reach for most people. It's created this huge barrier in the AI world. So, what if you could get all that AI brainpower, but without the colossal price tag and energy bill? Well, this is where the hero of our story, the David, steps into the picture. Meet the small language model, the key to making AI accessible for everyone. All right, so what is an SLM exactly? Think of it as the lean, mean, efficient version of a giant model. By using way fewer parameters, it dramatically cuts down on computational costs and energy needs. It's all about finding that perfect sweet spot between performance and efficiency. And that balance gives them some serious superpowers. First, efficiency. We're talking AI that can literally run on your smartphone, not some giant server farm. That leads to accessibility, because it's cheaper and easier for smaller companies to use, and you can keep your data private by running it locally. They're also super easy to customize for specific jobs, like analyzing medical records. And maybe best of all, they're fast, giving you those instant responses you need for things like real-time chatbots. Okay, this all sounds amazing, right? But how in the world do you actually shrink an AI without, making it dumber? Well, it's not magic. It's some really clever engineering. So let's pull back the curtain and see how they do it. It basically boils down to three core techniques: distillation, pruning, and quantization. Now, they might sound a bit technical, but trust me, the ideas behind them are super cool and pretty intuitive. Let's break them down one by one. First up, we have distillation. And honestly, the best way to think about this is like a wise, experienced teacher passing down a lifetime of knowledge to a really bright student. So you see here, you've got this massive, super smart teacher model that's already been trained on everything. What it does is it guides this smaller student model. The student learns to copy the teacher's answers and reasoning, essentially compressing all that knowledge into a much smaller, more efficient package. And this isn't just simple copy and paste. It's way more sophisticated than that. The student doesn't just learn the final answer. It can learn from the teacher's thought process along the way, or even by understanding the complex patterns and relationships the big model found in the data. All right, technique number 2 is pruning. If distillation was like teaching, think of pruning as, well, expert gardening. It's all about strategically trimming away what you don't need to help the whole plant thrive. So check this out. After a big model is all trained up, the pruning process kicks in. An algorithm goes through and finds all the weakest connections, the parts that aren't really pulling their weight, and snip. It just removes them. This makes the model way smaller, and then it gets a little fine-tuning to make sure performance stays sharp. It's all about targeted efficiency. And for our final trick, we have quantization. Now, the name sounds super technical, I know, but the idea behind it is actually pretty simple. It's about making the model store its information more efficiently by using, well, simpler numbers. Look, a big model might use these super-duper precise 32-bit numbers for all its calculations. Quantization basically says, hey, do we really need all that decimal point precision? And converts them to something much simpler, like an 8-bit number. It's kind of like taking a massive high-res photo and saving it as a JPEG. You lose a tiny bit of detail you'd probably never notice anyway, but the file size just plummets, and for a device with limited memory like your phone, that's a total game changer. All right, so we've geeked out on the how, but now for the part that really matters. Where are you actually going to see these things? The answer is, well, you're already using them. We're talking about incredibly powerful AI living right in your pocket. The idea of smaller models has been around for a bit, but just look at this timeline. Things absolutely exploded in late 2023 and into 2024. All the big players, Meta, Google, Microsoft, are jumping in with both feet. This isn't some niche experiment. This is a full-blown movement. And we're not talking about theoretical models here. These are real-world tools that are out there right now. You've got things like Meta's Llama 3.1, which is a fantastic balance of power and size. And on the other end, something like Tiny Llama, which is built from the ground up to be incredibly light and efficient for your phone. These names are becoming just as important as their giant cousins. So why should you care about all of this? Well, because you're literally using SLMs every single day, probably without even realizing it. That predictive text on your keyboard that finishes your sentences? Yep, probably an SLM. Using Google Translate when you're offline on vacation? That's an SLM too. They're in your smart home devices, your car's voice command system, and those helpful customer service chatbots. They make AI feel seamless. Okay, so this brings us to the big question. LLM versus SLM. Who wins? Well, you know what? That's actually the wrong way to look at it. It's not about which one is better overall. It's about picking the right tool for the right job. Think of it like this. If you need to write a whole novel from scratch with deep characters and a complex plot, you want the powerhouse LLM. But if you just need a chatbot that's an expert on your company's refund policy and nothing else, an SLM is the perfect, hyper-efficient tool for that specific job. Now, when we talk about resources, yeah, it's not even a fair fight. LLMs are the gas guzzlers of the AI world. They need specialized, expensive hardware and tons of power. SLMs, on the other hand, are the efficient hybrids. They're economical, they can run on the hardware you already have, and they're way faster to get up and running. And finally, let's talk about where this AI actually lives. LLMs almost always live in the cloud, meaning they need a constant internet connection. But SLMs, and this is their killer feature, can live right there on your device. This is huge for privacy because your data never has to leave your phone. And it means you get responses instantly. No lag, no waiting. So there you have it. Small language models are proving that they're not just smaller versions of what we already had. They're making AI more accessible, more efficient, and way more personal. They are the nimble Davids proving that sometimes smarter is better than just bigger. Which leaves us with one really exciting question to think about. What new doors open up? What amazing possibilities are unlocked when powerful AI can run on any device, anywhere in the world?